My job's a program director. Anyone else in sort of on the project side of Agile in here? Yeah. Who's in a team, on an Agile team, right? What about product people? Any product people here? Cool. Okay. What I'm going to talk about today is the approach that we use at Envato in the market division, the division that I'm working in, and we've been using it for about 6 months, and it's about different ways of forecasting projects. So hopefully you understand it. I love last conference. Was anyone in the right? No idea what just happened to me. And that's sort of what happens all day long at last conference. Best conference of the year. You just get lost in it, and encourage you to do that. I don't know what it was, but I loved it. And hopefully you love this one too, and maybe I'm really hopeful you know a little bit more about what's going on. So estimation's a controversial subject, has been for maybe at least the last couple of years in Agile circles. Should we estimate at all? Should we? How should we do it? They've got a big no estimates hashtag that took off, and Neil Killick locally speaks quite frequently about no estimates, and I followed it for a little while, wondering how to practically apply it. So the argument's very clear, and the passion's certainly in the arguments. Sorry, I wouldn't say the arguments are clear. This is my point. Is I couldn't really work out from this whole drive towards no estimates how to actually apply it. So my job is to work with about 80 people, and as their Agile coach, and I have another couple of coaches who work with me. So how would I take this idea and translate that into some practical things that my teams, not my teams, but our teams or the teams I was coaching could do to implement a no estimates system, a system. So I'm probably a person who thinks that way, like a process person, and I'm interested in the processes teams establish for themselves in building their software and the systems that they recognise within that. So we've developed, or I've developed, and now shared with the teams, and it's been adopted and liked in some quarters, and not adopted and not so liked in other quarters, a way of looking at forecasting projects that's a little different to what we've done historically. So I'm going to start I've got to start my slides, because how long do I have? Anyone know? I haven't done this talk before. Could be 40 minutes. Okay, and if I do that, don't get the speaker's notes on here, so we're winging it. Okay, how do you do? Anyone use comparative size and velocity for estimating? Who uses comparative size estimates? Who uses story points? Same people? Yeah, it's the same thing. Who uses velocity as an indicator for future project forecasting? Who does nothing for future right? Of the people who didn't put your hand up at all, and because no one put their hand up when they said they don't do any forecasting, what do you do if it's not velocity-based forecasting and comparative size estimation? Anyone?
We just basically trust the team.
Trust the team?
Yeah.
So how big are the projects? How much money? How long do they take?
How long it takes.
Yeah, are they big? They're 6-month projects? Are they?
No, usually it's about 6 weeks.
Oh, 6-week projects. Yeah. Okay, and they hit 6 weeks very often?
Most often. Yeah.
Most often, cool. Anyone else? What do you got?
Cycle time.
Cycle time, grouse. We're going to talk about cycle time today. Okay. I've always done it. I love I love estimating stuff. I love it with my teams. I think it's a great way of facilitating good conversations about the work to be done and the solutions that we might build together. Love it. Never trusted an estimate in all the time I've done it, and have never really, in my time as a program manager and program director, never expected that the estimate was anything like accurate. My consideration of an estimate on a story card, on a user story, on a card or on a ticket or whatever, is that it's a signature for the team. We have had a conversation about this, and it's led us to the point at which we're all happy to say, let's close the conversation by saying it's a medium story or a large story, or we think it's a whatever. That's the only value for a team to estimate from mine. To facilitate them coming together around an idea and discussing it and saying, oh, we all get it now, let's call it a large. seems bigger than another thing we did. That's enough for me. But to extrapolate that into some kind of mathematic projection for the future projects of that team always seemed a little bit iffy to me. So the no estimate stuff really did resonate. So I'm saying that comparative sizing and velocity is like, this is the velocity, right? And the space shuttle is the model. And if we look closer, though, at comparative size and velocity estimating, you can see it's a little bit buggered. It's still got dents in the nose cone and there's bits of sticky tape holding it together. It's like this space shuttle. It's really, this has come back from out of space, I think, and it's just a bit bashed up. I think velocity-based estimation and comparative sizing is very useful, but probably needs to be either decommissioned by NASA, or at least the space program needs to be supplemented with some more funding and something else that helps bring a greater clarity to our projects. Okay? So, velocity alone isn't great for teams. Problem with it mainly, I find, is that people are looking for a number, like how many sprints, or how many days, or how many weeks, or how many, like they're looking for a specific number. And it doesn't really give you, you can try, all it does is put pressure on people, because if you ask a team how long is it going to take, they say 8 weeks, then they feel that pressure, they feel the weight of that pressure. Even if you're saying, look, velocity is telling us 8 weeks, it comes from the team as an observed thing, as an opinion thing, as a subjective thing that the team is expressing. We think it's this. And then they feel that pressure every week, every week, every week, every week. If you said it's between 6 and 10 weeks or 6 and 10 months, would you have, back here at Mission Control, enough information to make the same decision as you would if you could be sure it was 8 weeks? How many times in your organisations would it be true to say, it's 8 weeks, let's do it. It's 9 weeks, let's not do it. Very infrequently. So what I'm saying, and what this method does for you, is build ranges. Build ranges. I think I get to talk about that now. So there's 3 things we do. It's a session we run, and what I'm going to take you through the session that I run with the teams. I take them through it. They run it, and in doing so, I'm going to introduce you to the 3 things that we would do in trying to help a team forecast its future project. Okay? Now these are projects of between 6 weeks and 3 months, say. Not 5 years, not 2 years. So maybe a 3-month type project, okay? Monte Carlo is the first blind mouse. 3 blind mice. I call this talk 3 blind mice because there's 3 modes of estimation and they're all blind. They're all speculative and they should be taken as informative inputs to a conversation that you should have with your teams and organisation, rather than a gospel truth on how long this is going to take or how much this is going to cost. Okay. Monte Carlo is the first one I'll talk about. It's where I'm going to spend most of my time, because it's the one. Who knows what it is? One person knows how to do it. Yep. One person knows how to. What are you doing here? Why? If you know how to do it, one person knows what it is. One person knows how to do it. That's where I'm going to spend my. Who knows what story point estimating is? Right? Most people know. So most people know the other 2 things. I'm going to spend most time on Monte Carlo. All right? That's what I think is the most value. Anyone read this? How to Measure Anything? It's a pretty good book. Okay, it's not an agile book. It's a book about business analysis, I suppose, and decision making in business. And Hubbard wrote it, and what he's done is his suggestion, in part of it at least, is that ranges of information are just as valuable and far easier to produce mathematically from very small sets of data often than lead to enough information, just as good information, to be able to make a decision organisationally. So he's saying, like I said before, don't try and spend months and months doing so much analysis that you think you've got a specific estimation of the value delivered or the time it's going to take or the cost it's going to take. He's saying, do enough, get yourself confident that you've got a range of information that would lead you to the same powerful decision. Okay? The good book, you should read it. How to Measure Anything. Jimmy Ross gave me that book. Now, who knows what Tact Time is? This is where it gets to the agile stuff. So that's not an agile book. This is how I've applied it in an agile from an agile or a software building perspective. Anyone know what Tact Time is? Tact Time. Okay, cool. Tact time is a lean idea. It comes from manufacturing. Tact is a German word. It's like heartbeat, or the tact is the rhythm of the orchestra. The guy, what's he called? The conductor. He's keeping the tact for the orchestra. It's the beat, the rhythm. Okay. Tact time in manufacturing means how often does a car come off the end of the line at Toyota? Every 7 minutes, we've got a 7-minute tact time. Bang, 7 minutes. Bang, 7 minutes. Bang, 7 minutes. 7-minute tact time at Toyota means we can produce 10,000 cars next month because 10,000 cars have been ordered. It's very important for just-in-time manufacturing because they don't build the car until it's been ordered, and that means they need a way they can speed up the line or slow down the line according to how many orders they've taken for next month, and they know that they're going to be able to build them that way. So every 7 minutes, boom, 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 a car plops off the end of the line at Toyota. It's the tact time. So another way of thinking of it is these things. These are a cable car, or a ski lift, right? Every 2 minutes, I don't know how, I've never been skiing. How often does the ski lift arrive? Every 20 seconds or 30 seconds, I suppose. They just keep coming. Now, sometimes they've got one person in it, sometimes there's 3 people in it, sometimes the 2 people in it weigh 100 kilos together, sometimes you get one person who weighs 100 kilos sitting on that thing. But every 20 seconds, this chairlift is bringing someone and plopping them down at the end. That's the tact time. 20 seconds, plop, 3 people. 20 seconds, plop, 1 person. 20 seconds, plop. Oh, no one on this one. But every 20 seconds, something happens. Okay, good. Cool? It's not like cycle time. Cycle time is how long it takes, on average, I suppose, to get through a story. Right? Not like cycle time. This is the time between successive completions, successive deliveries. Got it? I'll show you a little bit more, right? So this is an example for one sprint, 15 minutes. Okay, so the tact time, these are all user stories. This is a 10-day sprint. These are all user stories. First one happens halfway through the first day, team delivers a story, finished. Tact time is 1.5 days. On the third day, that's 1 day past this one, 1 day after the first one, they delivered a story. Tact time on that one is 1. They don't deliver another story till day 6. 3 days after, 1, 2, 3, I did that right. 3 days tact time on this user story. 2.5 to the next one. Then 2 days tact time for the next story, but it's delivered at the same time as another one. This one has a tact time of 0 because it came, although it came at the same time as this one, well, it has its tact time of 0 because it came at the same time as this one. Okay, so tact time is something you can monitor. It's useful, and I like to collect it per sprint. Actually, all you need to know is how many stories were delivered in each sprint, because the tact time is the average of all of these ones, about average of all of these, see? The average of all of these, including the 0, is 1.66. For this sprint, the average tact time for stories delivered was 1.66 days. Got it? Leads you to a pretty easy or pretty straightforward formula. If you want to know how long your project is going to take, and you know how many stories there are 50 user stories in my project, then I should be able to just go 50 times 1.6 equals what? 70 days or something? 70-day project, right? Easy. And I'm done. No, I'm not done, because you can't just take one sprint, right? This is one sprint. That's the formula. Project duration equals the number of stories times the tact time. It's straightforward and it's the right one to use, but it doesn't take into account the uncertainty that we all know lives within our software projects. Uncertainty is not something we experience alone as software development practitioners. Uncertainty is something that people who are trying to model results have always had to deal with. How do you think, when you do a drug trial and they trial it on 100 people, how do you think they extrapolate that out to an entire population mathematically? There's a lot of uncertainty in that. How do you think they... you can come up with a million examples that are the same. We're not the only people who have uncertainty. We're not unique in that regard. And we can learn from other fields about how to work it out. So, this is the uncertainty. So I've got 10 sprints here. This is 10 real sprints of data from one of our teams here. So there's 10 days in this first sprint. They deliver 6 stories. That's the first one I showed you, right? The next 10-day sprint, they only deliver 3 stories. That's a 3.3-day tact time, average tact time. There's 10 here. Everyone got it so far? This is where it gets cool for me, all right? I've got an 8-day sprint with six items delivered. It's a different tact time than the 10-day 6-item sprint, of course. This is how it goes. Look at the variation here. We've got a 5-day tact time for 2 stories. That's 5 times the tact time of this sprint here. How could we take this seemingly, it's just up and down life of our team and turn it into something that will help us forecast a project? Well, the answer is Monte Carlo and bootstrapping. These are not agile terms, these are mathematic terms. Monte Carlo is the method used that I'm going to show you, and bootstrapping is the method is the method used when the inputs are very small. So I'm going to show you that you can use only 5 sprints worth of data, historic data, to extrapolate that out into a project plan. Okay, this is what I've got. Some animation. I've been working on this all week. Ready? There you go. Let's take our tact times. Come on, yeah. Just do it again. So there's our tact times, right? Now this is the practical stuff. You want to take notes, this is the time. You take your 10 tact times. Average tact times from 10 sprints for this one team. There is uncertainty here. We can all see it. What this mathematics does is assume that this type of uncertainty is typical for this team and will continue. Probably true. So let's take, ready, 5 of those at random. Not all 10, I'm just taking 5. If I add all of those together, the 5 tact times that I took, 5 real tact times, including 1 duplicate, you see, this is how long it takes. This is the sum total of all those tact times, right? How long did it take to deliver 5 items by this team? This amount of time. Now, how did we derive an average tact time from our sprint before? We did number of days divided by number of stories equals a tact time. We can do the same thing here. So we can, this is bootstrapping, we can say, see that one? The 8.49 days divided by 5 stories delivered, 5 stories in this case, equals a new sample tact time, which is a realistic probabilistic interpretation or prediction of what might be a typical tact time for this team. Another one, even though they never did it. We've taken 5 random samples, we've made a new one. 5 random samples of real data to make a new probabilistic and realistic new sample tact time.
Next question.
Yeah.
Why wouldn't you take out the high and the low and use the medium in the middle to get more?
Because we're not just going to do that once. We're going to do it again, and again, and again, and again. Putting this is why you can use a small. The bootstrapping bit is how you can use a small subset. If you allow for duplicates, right? So I've got 5, say I only had 5 sprints worth. I can use 1.25 twice, that's fine. It's entirely likely that it's entirely reasonable that this team will deliver twice on that same schedule. So if you allow duplicates from just 5, there is 5 times 5 times 5 times 5 times 5 times 5 combinations that you can randomly choose, and Spreadsheet will let you do that. So we can do this thousands of times. Here I've got 1, 2, 3, 4, 5 reproduced, simulated tact times, reasonably simulated tact times for this team, right? Just 5. But I don't do this 5 times, I do this 1,000 times. And a spreadsheet will let you do that 1,000 times just like that. So from 5 inputs, so I've got 10 inputs in mind, but from as little as 5 inputs, I can build, with a spreadsheet, 1,000, 10,000, 100,000 randomly created, reasonably probabilistic samples of a tact time that this team will produce. Got it? It's not my theory, but that's how it's done. So now I've got 1,000. Now I've got 1,000 sample tact times for this team, and we're going to accept that they're reasonably probabilistic, realistic. Okay, 1,000 of them. Now what do we do? It shows us this, a distribution. Now this is what I'm talking about. We're not saying that this team delivers 1.66 every single time. We're saying that from our 1,000 reproduced samples of tact time, this is the distribution, 2% of them. were 1 day. I'm rounding to a quarter of a day here. 2% of them rounded to a quarter of a day. By the time you get cumulative performance here, 14% of them were 1.25 days of these simulations or less. As you go to the right, 1.5 days came in at 35% of all results were 1.5 days or less. So we've got a distribution here of tact time. Yep.
Does this change depending on the complexity of what's being delivered though? So if the stories or whatever is actually being delivered by the software team is not taken into account, does the same modelling produce the same results?
It does, and well, it does, because it doesn't account for what's in the story. It's just counting the stories. It's just saying we're going to. It's an external observation of this team's throughput. It's saying, I don't care what your story is. I don't care if you've got a thing that you're building a website to sell bananas, or if you're building a thing that runs the thing that keeps a bloke alive in the hospital. We're just going to count how many stories you put through every week, and we're going to use that to we're going to take random samples of that to build a model on which we can learn your future performance. Okay, so this is how we go. We get to a 97% confidence factor that this team will, in the future, deliver on a 2.5 days or less tact time. But that's not really what's the interesting part. Taking this one more level to where we get to a project forecast is where it gets interesting. So I've taken 10 samples of real data, built 1,000. Built 1,000 tact times. Now, I want the second part of my formula, which is, how long would it take to do 35 user stories? I've now got 1,000 sample tact times. So I run 1,000 times simulated projects of, how many did I say, 35 user stories? Simulated projects of 35 user stories, randomly sampling from my 1,000 tact times. And that's going to build me another range. So the project duration distribution, which is a new distribution, equals the number of stories by random probable tact times. That's the distribution. I'm not telling you here that I can predict exactly when this team will deliver its story. I'm telling you I can show a mathematic simulation of 1,000 projects of this team based on something I really know about them. All right, keep going. So we do it again. I'm going to take 35 stories out of my 1,000 and I'm going to add it up and see how long it took. I'm going to do it again and again and again. No animation here. I'm going to press a button and again and again and again until I get this. So for how many stories here? Don't know. However many stories were in this, we've done the same thing. We've gone, we know some tact times. Let's extrapolate that into 1,000 tact times. Let's randomly sample those 1,000 tact times 1,000 more times and say, how many, out of it, let's run 1,000 project simulations for 35 user stories. And we get this. This is what we get. Sprints. 6 sprints. 2%. Model says 2% of this. If we had that many stories, 2% of the time, they would deliver this in 6 sprints. 11% of the time, model thinks they would deliver this in 7 sprints or less. And so on across here. Now, this is the same maths. I've worked on this with a guy who does this. This is the same spreadsheet, the same math used to extrapolate drug trials. And this is what they do. They say, they build a confidence level. So in my confidence level, because I'm not trying to save the planet, my confidence level can afford to be a lot lower. This guy says, I'm not happy unless I get 98% certainty. That's where I'm going to put my pinpoint. I'm going to talk with the team now and say, listen, I'm flipping a coin at 9 sprints with you guys. What do you think? You told me when we walked in the room and I asked you how long you think it would take, you said 5. I'm flipping a coin at 9 based on this. What do you guys think? And it leads us somewhere pretty special. It leads us to a complete removal of a feeling of responsibility for that outcome, for that forecast. Team now says, oh, fuck, thank God it said 11 sprints, because that's what I really thought. But I thought you wanted to hear 5, so I said 5. And they walk out of there going, spreadsheet said 11. Okay. So we take that, and I'm gonna get back to this anyway, but I want to really quickly, blind mouse number 2 is in the same session. That's the important stuff, and we're going to talk a little bit more about that because we've got a little bit more time. Blind mouse number 2 is we just take all of the user stories that are already in Trello, we duplicate the Trello, and if we've just had the discussion that said, what do we say about 9 sprints? I just let them go for 10 minutes. I say, I've duplicated your Trello, we're going to chuck it out in 15 minutes. I've put 9 sprints on it. Let's chuck all of the stories that are in your backlog now, the 35 that we talked about, let's chuck them all into 9 sprints and see how it looks. Let's kick that around. And they do that. And it's another discussion. Yeah, that one, I reckon we could do that one. Oh, let's back end that one. There's a bit of front end here. Oh, geez, we forgot a story. That leads us to this. Something that looks like this. And then the last one we do in that same session is have a look at velocity. So on top of recording number of stories per sprint, we're also looking at team velocity, and we're able to say, look, it probably gels or it doesn't gel, or we're able to say on velocity, hey, the spreadsheet's worked out this, you guys say another thing. On velocity, we can see that you're going at an average of 11 points a sprint. The 9 sprints here says, what does it say? It says 18, 17, 17. Look, would you be able to go at that rate, you reckon? What do you think? What's changed in this team since we took those data points? So those are the 3 blind mice. We do this big mathematic, we have a bit of fun and have that, and it's not, well, sometimes we have fun, sometimes I get guys who don't really like doing this and they, it's not as much fun. But by the time we're finished, we've had a 3-way look at it. We've done this mathematical model. We've had a sprint, chuck them into sprints, and we'll see how that looks. And then we've had a look at velocity too. This is the one that most teams just usually do, velocity, right? Okay. I'm going to show you the spreadsheet I use. We'll just do one. But these are if you want to write down some reading, this is to do. I'm going to have a go at their names. Dimitar Barkadzeyev, Vasco Duarte, he's unreal. He's a Bulgarian, and he has YouTube stuff about him. He's got a website. He's a consultant on this stuff, but he's pretty serious, and he's good fun to watch. Vasco Duarte, really serious no estimates guy. Just got a new book out, No Estimates, I think it's called. Douglas W. Hubbard, he wrote How to Measure Anything. Troy McGuinness, he's good fun too. He's they talk about these sorts of things, all of these guys. And No Estimates hashtag, go there and just get down into some of the worst aspects of the internet. If you're really keen on depressing yourself and looking at some fights, that's where you go. No Estimates on Twitter. This is my website, scrummage.com. It's a blog. I've got I've got a blog post that I just put up there this morning that's a sister post to this talk, because I figured you'd all walk out, forget everything I said. You can go here and go through pretty much the whole thing that I just talked about, and you'll also get a link to this, which I'll show you now. This is a Google spreadsheet, Google Sheet. Now I have to find it. That project simulation. Okay, good. So this is a Google spreadsheet that this is what I use, right? And we'll do it together now. So, what have I got? Oh, this is the stuff I used to work out what I was going to show. Okay, so let's do it again. First sprint. Watch what happens here. How many stories in the first sprint? Yell it out. 6 in the first sprint. Who's got some other numbers? Who's got some ones that aren't 6? Like, do you guys, any of you got 14 stories or 20 stories completing a sprint? 80. 18's all right. 18. Let's do 18. What's another one? Watch what's happening here. We're building them, right? 6, 18. As we go, this is building tact times for those sprints. What did we say? 14. Geez, we did all right in that 8-day sprint, didn't we? Right. 14 here. It's building them. Let's do another couple. 2 grouse. And 10. I'm going to say 10. Let's do that. Okay. Good. Now, this is where the maths happen. It's all just spitting out here. These are my tact times based on those numbers. Got a 1, 0.44, got a 5, got a 1, builds a tact time over here. Days to deliver, tact time for that. 1,000 times. I use 1,000 times because I'm using Google Spreadsheets, and if I did 10,000, like I said, this is a good start of a conversation. I'm not trying to work out how to beat AIDS in the state of Victoria. I'm trying to do something far less important. Yep.
So is this predicated on having the no estimate start stories equal size?
That's a really good question. Right. So the question is this predicated on doing no estimates in stories? No, it's not. Most of our teams still use comparative size estimation. What it's predicated on is two things. Firstly, having a reasonable confidence that you've got the right number of stories. So if it's 50 stories in the backlog on day one of the project and it grows to 120 stories, this is no good. So you want to have a good inception, you want to have a good knowledge of that. That's one. The other one is that user stories are consistent in the way that they are written and in the way that they are sized. So most of the no estimates argument is make them all the same size, most of it, which in itself is an estimate, by the way. So all it says is it a user story? That's all. If you can get to a point where you're saying it's user story sized, it's not epic sized, it's small enough to be called what this team calls a user story, and that's consistent, then it works. That's it. But if you've got, and it doesn't really matter, like if some user stories are big, some are small, it doesn't really matter. But if you're at least able to say we'll be consistent in determining what size feels like a user story, and we know that we've got 50 or 80 or whatever, now it works. But you can estimate it. In doing normal traditional estimates on your story point estimates, you're doing the same thing. You're saying it's a user story. And maybe that's what I'm saying in my first statement about estimates is whether they put a large, medium, or small, or a 2, or 4, or an 8, or a chicken, a pig, and a horse, or whatever they're using on their user story as their scale, all it means to me is they talked about it and I think that's a user story. That's it. Yep.
So if you know that you're going to discover more stories along the way, do you plug in 1 or 3 more stories discovered per iteration?
Yeah, yep, for sure. Yep. For sure. That's the confidence you want to have. You want to start this discussion with, right, let's have a look. We'll do this. How many, your last project started with 70 and ended with 80 stories. Last one started with 40, ended with 80. Is that going to continue? And let's put in the 80 if that's what we think. The other thing we can do here is program focus. So we call this program focus. So we know how many stories were delivered. We know what percentage of those, we keep record on this, we know what percentage of those were related to the project. So our teams don't just work on a project. They work on one thing. They work on building a big feature, but then they've got stuff that comes in and they also class those as user stories and write them and add them to the backlog as they go. So you might have delivered 10 user stories, but 6 of them were related to this project. So we're going to say, we can look at that history too and say, well, is that going to continue? You're going to get 60% of a go in any one sprint to work on this project. You're going to only be able to work on it 60? Okay, well, let's plug that in. We're going to say that you've got a 60% project focus here, and that's going to bring these numbers down, which in turn brings the tact down, up, and changes these numbers. That gives us the tact distribution on the next thing. Whoa, look at because we went up and down, see? This is cool. It's the team. We can also say, well, looks like it's pretty heavy duty. Let's make it half a day, and we'll round everything to half a day on tact and see if that smooths things out at least. Gives us the same data, but just less kinks in it. We'll still reach the confidence at the same level. And the next one is our project simulation. So there's really very little data to put in here. 35 stories, we said. Here it is, 35 stories. The distribution for this team looks like this. Pretty up and down. Because of our up and down, we had a 2, we had a 20. But what we're saying is, that's the real world for this team. They're not a team that has a consistent or a predictable throughput of stories. That's what we said. I'm not about to make it up that they are going to have a predictable throughput of user stories. We're just going to take it and say, this is exactly what you did in the last 10 sprints. What have we got finishing? And this is probably what could happen going forward. We reached 97% here, 98% of 20 sprints. But it's real world stuff. And I'd rather be able to say, this might be so up and down in their history, that it looks like that. And it's probably going to go forward. You can also have some conversations about changing things. Is it even desirable to be less up and down? Are there things you could do? Yeah. So this here, and the growth of stories leads to conversation like, how are your stories defined? Are your stories descriptions of activity, or are they descriptions of deliverables? If you've got if you're wedging team activities into user story format so that you can just describe the work you're doing week after week, it's always going to grow by 20 user stories over 30. But if you're doing, we can have that talk now. What do your stories look like? Are they activity-based? Are they defined as features delivered? Because you're not going to find 30 missing features that you didn't think about 3 weeks ago. Yep. Yeah. Well, yeah, I suppose. I mean, I don't do it. Like I said, as I said, the biggest thing I'd use on this is a 3-month thing, and that's because it's something you throw into. I'll throw into one team for 3 months, and it's the most that they do. And this is useful. If I've got something that lasts more than 3 months, it's probably now going to impact more than one team, and it probably requires a different approach to planning than what a more heavier probably approach to planning and discussion than what this gives me. But read these other guys. Like, read those books. I'm showing you something that's pretty lightweight. It's a toy compared to what Hubbard's going to tell you about, or Dimitri's going to tell you about, or McGuinness. This is a toy. These guys are scientists. All right, go and have some lunch. Hope you have a great last. Oh, yeah. Again, scrummage.com. You can get a link to this spreadsheet, and you get another description. Scrummage.com.